almost 19 months since the virus first emerged like a sucker punch and knocked all our lives out. Over 4 million lives have been lost across the world. Physical distancing is the new way that we've been told to live. It was during the pandemic we started our project, the nation's digital hospital, a telemedicine portal where you can consult a doctor online from anywhere, anytime. All what you need is to sign up by visiting our website www.ndh.lk or just use your smartphone to download the app. You can always use your Facebook, Instagram or YouTube channels to reach out to us. And all the links are mentioned below. Hello and welcome to NDH. I'm Champa Samravira. Today I'm at this beautiful venue, the Royal Holloway, University of London, to talk about a very interesting topic that's going to reshape the way we live, the artificial intelligence. A lot of us are curious about AI. Today we are less scared of the robots and more scared of them taking our jobs. A lot of us use artificial intelligence in one way or the other without even we noticing it. The Google searches we do are based on the previous information and the websites that we visited. And if you are using Instagram or Facebook, the adverts that are being thrown in are based on what you speak in front of your smartphone. And no one is doing anything behind a computer. They use algorithms to learn about us and from us to make things better and better. Today we are going to talk about how AI will change the way we receive healthcare. And I'm being joined by the professor in charge of machine learning at the Royal Holloway, University of London, Prof. Watkins. He's got a very impressive CV behind him. He's done machine learning from the very beginning, and that takes us back to the 1980s. And he's also the inventor of the Q-learning, one of the very basic forms of reinforcement learning. He's also worked for the Philips Research, AT&T Bell Labs, and 3 other investment companies before joining the Royal Holloway in 1997.
Professor Prof. Watkins, thank you very much for joining me today and thanks a lot for making time. So let me ask my first question. How do you think AI would change the way we take medicine?
It's a great question. Let's think about what AI is good at. AI is good at taking lots of small, easy decisions where getting it wrong doesn't matter too much. So the examples you mentioned at the beginning of, say, Google deciding which advertisements to show you, that's a great example. Hundreds of millions of people use Google every day, and Google makes hundreds of millions of decisions on what advertisements to show. If it gets it wrong, it's really not that important. You see an advertisement you're not interested in. Nobody loses much. But if it gets it just slightly more right, they can, and they do, make very large amounts of money. Now, medicine doesn't seem immediately like an area where there are lots and lots of small decisions where mistakes don't matter. But on closer inspection, maybe there are. There are a lot of jobs behind the scenes in medicine where people are doing repeated things, doing the same blood test, looking at similar x-rays, looking at similar test results many, many times and making decisions based on those. What AI can do is make those decisions more consistent. If you have a program doing that, a machine doing that, then the machine doesn't have moods, doesn't have slumps, it doesn't have lunch, it doesn't have after lunch, and if it has biases, well, you can identify the biases and you can correct them. So behind the scenes decisions, these are, if they're carefully designed, a really great application for AI. What is much more difficult to do with AI is to have a system that can consult with your doctor. You might imagine the robot doctor and the human doctor talking to each other. The robot doctor, so calm, so reasonable, so knowledgeable. The human doctor, so insightful. This is not going to happen for a very long time. Robot doctors can't talk to human doctors. They cannot have a reasonable conversation. You cannot combine the evidence and the arguments from the machine intelligence with the insight of a person. So that's more difficult. But it doesn't mean that there aren't many other applications. For example, we already use simple kinds of algorithms in medical practice where people are warned about taking their tests and getting their medicines and taking their medicines. And doctors in the UK already have, when they bring up the patient details, they have little pop-up windows saying, have you considered this and have you considered that? Sometimes they find it really annoying. And this is a good use of AI because what you're doing is you're enhancing the human's decision-making by simply reminding them of a number of likely options. So I think that, as in other areas, to actually answer your question.
Yes, you did.
To actually answer your question, like in other areas, there'll be quite a lot of AI that you don't really notice behind the scenes, helping to make a lot of small decisions quickly. Oh, when you don't notice AI, that is a good thing. It means it's just doing its job. It's not being super smart. It's just doing its job, just not to get noticed.
How can we be sure that AI is accurate?
That's a real topic of current research. Now, it's an interesting question because even very statistical rules are a very simple form of AI. And from the beginning of multivariate statistics in the 1950s, you could get a stack of a few hundred case reports where you have lists of patients' symptoms and their diagnoses, and you train a statistical algorithm to predict the diagnosis from the symptoms. There are a limited range of things in one hospital. And then the statisticians could be very happy because they could humiliate the senior consultants by providing more consistent diagnosis than them. So you might ask, well, why aren't we doing this everywhere for everything already? The reason is that doctors have a very wide range of knowledge, and when they see a patient, they can pick up many different kinds of information. You can't anticipate what you'll find out. And people are really good at integrating many different kinds of information together to come up with plausible reasoning. Now, AI, not so much. You see, the AI doesn't really understand. It is, in the present state of our technology, most of what we call AI is matching patterns. But it doesn't understand what it's doing matching the patterns. It's simply making a decision which is similar to many decisions that it has been told were made before. So this has a real problem, because if you train a machine learning system to make some particular decision for, diagnosing whether someone's got a cold or not, or whether they might be given antibiotics or not, or something like that, and then you set this system to work, or you might have it examining a breast screening X-ray to see if there is an abnormality. If you put this system to work, then it may make lots of correct decisions, but if But nothing stays in the real world, nothing stays the same for long. The types of decisions you're going to want it to make will change slightly over time, so that you don't actually know what the system is going to do in response to the new types of data. For example, if one is looking at X-rays, then the camera setup might be slightly changed one day, or there could be a new machine, or any number of small irrelevant things might be changed, but this might change the accuracy of the system. So the same goes for lists of symptoms. So there is a very innocent sounding phrase which is used about AI systems, which I was just talking about this morning in another context. It's called continuous deployment. It sounds like a really boring grey phrase. Continuous deployment. What does this mean? What it means is you've trained up use machine learning to train up an AI system, you deploy it, you put it to use, and each day you don't quite know whether it's going to work or not. You don't quite know whether if it doesn't work today, if it starts making some wrong decisions, you won't quite know why, and you may have to retrain it or take some action which you can't anticipate. That's continuous deployment. Well, continuous deployment is fine for Google and its advertisements. It's what it does. But continuous deployment is not so fine for other systems, because it's really almost a new kind of software engineering. You have a system which can do wonderful things, but you have to constantly check that it's still working. And if it's not working, you have to figure out why, figure out if there's been a change in the data or what change in the data there's been, and correct it, and perhaps retrain it or make adjustments to make it continue working. So managing an AI system, so the answer to the question is, you've got to keep checking. We know the system's going to be correct if we keep checking it. And you have to keep checking it day after day, week after week, when it's in operation. So it can save a lot of work, but we have to trust because we verify. Now, there's a lot of research going on to try to improve the state of affairs. But, and if I say these are very interesting research problems, this means we don't have fully reliable practical solutions yet. That's why.
How is AI changing?
Rapidly and a lot. When I lecture, it's one of the points I make most. I teach a course on deep learning, and every year I change it, which is normal because each year you can teach something a little bit better because you've learned some more. But if I'd taught it 10 years ago, the subject wouldn't exist. It wouldn't be called deep learning. If I'd taught it 20 or 30 years ago, it would really be obscure. So AI has always been changing since the 1980s. But over the last 10 years and even in the last 5 to 7 years, there have been some really big advances in the things that AI systems can practically do. Now, we don't have self-driving cars yet. We won't have self-driving cars probably for many years to come, because that's a really complicated problem. But there are other problems which we have always thought are simple problems, which now can be solved. Now, as I'm talking, you, if you could write fast, would be able to write down the words that I say. This feels like a really simple problem. Now AI can do it, even against background noise. 10 years ago, it could not. That's deep learning. Nowadays, there is a famous XKCD cartoon by Randall Munro, in which the point of the cartoon is that some things in computer science are really easy and others are really hard. So if you want to take a photograph and say, was this taken in a national park? Well, that's so easy. You take the GPS location of the photograph and you find out if it's in a national park. That is something easy. Then, with the photograph, does it have a bird in it? 7 years ago, that was really hard, almost impossible. 4 years ago, it became easy. Now, you can set it up in 2 lines of code with the freely available open source machine learning environments from major computer manufacturers. So machine vision, locating and recognizing objects in images, is now, it feels almost routine. None of the young people I'm talking to watching this video will be in the least bit surprised. Of course, we can find faces in videos, we can see who they are and whether they're smiling or not. Well, I remember seeing the very first demonstration of a reliable, real-time face-finding system that could find a face in an image, putting a box around it, at a rate of 5 frames per second in 2001. That's 20 years ago. But it's become so much more accurate and so routine now. Matching 2 faces. Are these 2 pictures my face, the same person as the picture in my passport? Again, this is something that now we can solve reasonably accurately using deep neural networks. 5 years ago, 7 years ago, we could not. And there are a number of other examples like that. Things which should have been easy, and they are now easy. So, simple, stupid processing of documents, not understanding the documents, but simple processing of them, doing some simple tasks like extracting company names and so on, that's easy. Locating things in pictures, easy. Many perceptual tasks, easy. A reasonably reliable system for detecting intruders in a building, so an intelligent burglar alarm with video, now easy. 10 years ago, very hard. There has been an enormous change in these simple perceptual abilities of AI systems over the last 10 years. Now, don't get too excited, because the systems can still make somewhat stupid mistakes occasionally, and the systems don't really understand what they're doing, and they don't really understand what they're seeing in the world. But the point is that for about 50 years, computer scientists felt that the machine vision task of identifying a person or a car in an image, if it's clearly shown, should be simple, because there is so much information in the image. An image is an awful lot of information. A 2 megapixel image is 2 million times 3, it's 6 million numbers. And those 6 million numbers, you surely should be able to process those numbers to tell you if there is a car in the picture somewhere and where it is, and if there's a person in the picture and if there's a bicycle and so on. For decades, we couldn't do that reliably, and now we can. What will happen in the next 10 years? Good question. But I think that 10 years from now, AI is going to look very different than it does today.
What's the main advantage of using AI?
You can make simple, quick decisions reasonably accurately at scale very cheaply. So one of the mantras is that any decision that a person can make in less than a second, you can duplicate using machine learning with a machine. That is, you take 10,000, 100,000, a million examples of such a decision. You find the input, the images, the image, the sound, the words, what the person would have to make the decision, and the decision that needs to be made, and you train the machine on this. And we can now train machines to make these complex decisions. The order of complexity of recognizing a person or recognizing if there is a person in a building who looks as if he should not be there. We can do that, and the machine will then make these decisions consistently, repeatedly, and cheaply. Let's take an example of a company that is based on statistical learning systems making these simple decisions. So take the simple human skill of being a taxi controller. And sitting in the office, people ring up, they say, I want a taxi, and you have to decide which taxi to send to a place, how long it's going to take, and what the fare is going to cost to go from A to B. Well, you're able to do this as a person if you know the area and you have some experience. Uber has automatic systems that take these decisions at scale. None of these things are individually very complicated. When you hail a taxi, when you want to have a taxi, the company shows the ride, your request, to a certain number of drivers. How many? Well, too few and you won't get a ride, too many and it will waste its driver's time. It needs to estimate how long the driver will take to get to you. If it's wrong, it doesn't much matter. It's not the end of the world, but it's nice to have a reasonable estimate. It's never exactly right. How much will the journey cost? Again, this isn't a guarantee. So, in every taxi ride, there is a multitude of small decisions which an automatic taxi service takes automatically, millions of times a day. So this is how AI is deployed to advantage.
If AI is so great, why do we see so little being used?
I think we don't notice. When I land at Heathrow Airport, I go through the automatic passport gates, and there is a machine which looks at my face and matches it to my passport. That's AI. I don't know what kind of AI it is, but it's AI. It doesn't seem very intelligent, but it's a system we couldn't have built 7 years ago. I think there are a great many projects, AI projects are started and fewer finish because people don't take a cold, hard look at the problem at the start and figure out what the advantage of using AI would be, what the conditions of success are, what decisions need to be taken accurately, and most of all, how the AI would fit into the whole system. And so finding a feasible, profitable, maintainable, safe application of AI is not always easy. So many projects get some promising results at first, and then it's just not quite good enough to use in practice. That's normal. I think we are beginning to see a lot of projects because this generation of AI is being spread with extraordinarily rapidly. And this is because all the software you need, is free. It's being given away. It's extraordinary. Immensely sophisticated software, you can just download it. You can just download Python, TensorFlow, PyTorch. Personally, I code in Julia. All free. Your computers are very low priced. The cloud is even cheaper. So then the successful AI models and machine learning models, an enormous amount of different software is now available for free to download, and you can train it yourself. Trained models trained on millions of examples in very expensively in large industrial labs, research labs. You can download their trained models and then just try to tweak them or change them slightly to your own requirements. So this seems really new to me. I know that 20 or 30 years ago, I wanted to program in C++, remember C++, on my PC, and I went to the shop in London and I discovered that a Microsoft C++ professional visual C++ disk was going to set me back most of £1,000. Well, the idea of paying £1,000 for software nowadays, you wouldn't do that, would you? So the application of AI is being really driven by this extraordinary availability of free software, free advice, free blogs, free instructional courses, and YouTube videos, and a vast amount of both the basic tools that you need, the successful applications the research community has just built become immediately available for download, and then the commentary, instruction, question answering on Stack Overflow. All of these things work together to make this software extraordinarily available and constructible. And so we're going to see a lot more little quietly successful AI applications that we don't quite notice coming online.
What's next for AI?
The one thing we can say for sure is that AI is not going to be what we expect it's going to be. It's not going to be the Terminator, it's not going to be Dr. Spock, it's not going to be Commander Data, it's not going to be any of the robots at all that you have seen on film. It's going to be unexpected things. It's going to be, certainly in the near term, based on a lot of data. Let me give you one example. Suppose that in an effort you're trying to be funny and you make a joke. You have a little play on words, you make a pun. One word sounds like another and it's funny. Has anyone made that joke before? Google it. You'll be so sad. Of course they have. And Google knows. And that's the ability to find that play on words. Of course, it's AI Google Search is one of the most sophisticated artificial intelligence programs in the world. But the idea of living with a system that knows so much and can access so much is something which very few people properly anticipated. And when we have vehicles or intelligent buildings or cameras anticipating our moves or facial recognition which enables us to pay for things in shops without having to carry money, we are absolutely not going to anticipate the variety of uses there will be for this or how it's going to change our lives, any more than we could anticipate how the telephone would change lives, how the telephone answering machine would change it, how texting on mobile phones changed people's lives. The failure of imagination, in a sense, is of how we will use this technology. There'll be ways of using it, playful ways of using it, good ways of using it, and really annoying ways of using it that we absolutely haven't thought of.